This chapter deals with sort of introductory materials into capital budgeting. And this next problem we're going to work now, they're going to touch upon internal rate of return, how long you might be willing to wait for a project to give you the return you want. They're going to talk about the life of the project. And then they're going to talk some more about the cash inflows, how to determine what cash inflows you would need to make the project acceptable. Now, this particular problem reads like this. It says, Oak Enterprises accepts projects earning more than the firm's 15% cost of capital. So 15%, that is Oak Enterprises, that's their minimum acceptable return. That's their hurdle rate. Oak is currently considering a 10-year project that provides annual cash inflows of $10,000 a year and requires an initial investment of $61,450. Now the A part says determine the internal rate of return of the project and is the project acceptable. That's only going to be acceptable if it has a 15% or higher rate of return. The B part says assuming that the cash inflows continue to be $10,000 a year, how many additional years would the flows have to continue to make the project acceptable? That is, to make it have an internal rate of return of 15%. And the C part, it says with the given life and initial investment and cost of capital, what is the minimum annual cash inflow that the firm should accept? So again, they're looking at internal rate of return here, and they're asking you sort of, some ancillary questions about whether or not you want to make this project and what would the conditions have to be in order to make this project go. Often when you're looking at projects, you're dealing with somebody who wants to sell you the project. And so knowing what you need and knowing what to ask for now is sort of what this problem's about. So if you can negotiate these things, then you might be able to get the project for your company that's indeed meets your specifications. Now, in the A part of this problem, they want us to calculate the rate of return on the investment. Now, internal rate of return is the interest rate that sets the present value of the inflows equal to the present value of the outflows. And so if we set this up now, $10,000 a year, every year for 10 years, that's the inflows you get off this project. So that's an annuity. To find its present value, of course, you use your PVIFA. So we know that N is equal to 10. We're going to get 10 annual payments. That's going to be our inflow. And we want to set that equal to the cost of the project, the initial investment, which is $61,450. So we're looking for that interest rate that sets the present value of the inflows equal to the present value of the outflows. That's defined as internal rate of return. As you look at this equation now, what you solve for initially now is not this thing right here. What you're really going to solve for here is what's this interest factor have to be? Well, it's got to be $61,450 divided by 10,000, which is 6.1450. If you go to your PVIFA table, okay, and you go to the N equal to 10, as you go down to the left-hand column till you find N equal to 10, go across till you find an interest factor of 6.1450. To a couple of decimal places now, you find that where the column is you're in the 10% column. So when that's the case now, that means that's your rate of return. So this particular problem here, this project rather, has a rate of return of 10%. So would they accept the project? Well, the answer is no, because their cost of capital, their minimum acceptable return, is indeed 15%. So initial question, A part, just on its face, is this an acceptable project? The answer is no. The B part says, now, if the cash flow continues to be $100,000 a year, how long would you have to be in the investment to give you your 15% rate of return? So what we're looking for now is not I, but we're looking for N. So again, note up there in this equation now, we're not going to solve directly for n initially. We're going to find the interest factor that we need. And so if you take 61,450 divided by 10,000, you get an interest factor of 6.1450. And so if you go to the 15% column and then go down till you find an interest factor of 6.1450, you're going to find that it falls somewhere between 18 and 19. That means if this project earned $100,000 a year, you'd have to be in this project between 18 and 19 years in order for the project to give you a 15% rate of return. Are you willing to wait that long to get a 15% rate of return? I don't know, but that's the answer to that question. The C part now, they want to know, what if we can negotiate? What if we can, get more cash inflow? What would our cash inflow have to be in order to get a 15% rate of return? Well, again, your basic equation here, the inflow, which is what we're looking for, times our PVIFA at 10 and 15%. 10 is the original length of the project, 15% is our cost of capital. I'm going to set that equal to the cost of the project, which is $61,450. 5.0188. That's your PVIFA at 10 and 15%. Solve this equation for inflow. You take 61,450 divided by your interest factor, your PVIFA, of 5.0188, and you get 12,243.96. So if you can negotiate a cash inflow of not $10,000, but of $12,243.96, then you'll have a 10-year project that earns you a 15% rate of return. That's your hurdle rate, that's your cost of capital. That'd make this an acceptable project.